Okay, so we're gonna try this again. I tried to stream yesterday, and our power went out, so that kind of killed that and my learning for the day. And I swear, as soon as I load up the stream to get started, it starts raining. And I hope it doesn't take our power out again. But anyways, so here we go. Today's objective: linear regression using TensorFlow. So I've got this. I just wanted to be sure I'm on. It looks like I am. My drone battery. Oh, and a plug today. So today's music is gonna be, because I don't feel like listening to anything I did, is I think it's Emily Sprague, yeah. Water Memories. So Water Memory. So this is another modular synth artist. She is fantastic, and this is what I'm gonna play for at least a little while today. So if you like it, go listen to it, or go get it. Okay. So I liked this tutorial, and it seems, so there was another one that I was looking at yesterday. So TensorFlow linear regression was what I had Googled. TensorFlow JS. So yeah. So, and I like this guy's video too, he did. And he actually went on to... but I followed this tutorial and it made a lot of sense. And then basically later on he listed this tutorial as a reference, which is an official TensorFlow JS tutorial. And this actually goes through and does like a polynomial regression. I don't know what it's called. I know a linear is a straight line, but this actually like goes through, if you notice here, right, so the coefficient, yeah, so it actually tries to fit the curve, which is probably a better regression than, so if you notice here, if we wanted to predict the next one, we'd probably predict the next couple values to be right here. But if we had a linear regression, since overwhelming of these are going up, I would imagine a linear regression curve would look something like this. So that would predict a value here, and so that would be a pretty large error between here, this value, and this value. So might be better. I think we're going to work towards it, but we're going to start with y equals mx plus b, a linear regression curve. So what's cool is, so he's got these code pens, but basically this right here shows what's going to happen is we're going to start off with just kind of picking a random set of values, and so this first curve is going to be like dead wrong, and then we're going to train the model, which is basically like, if you know anything about machine learning, right, what happens is okay, there's a lot of different pieces here, but what we're going to try to do is we're going to train a model, right? And so our model is going to more or less be our output from the linear regression, and then we can use that model to predict or just get values off, or predict values from the model. And so we want our model to be as accurate as possible, and so what you do is you train the model, right? And so like this first one's wrong, and then so we're like, okay, we'll try again. Like we think that if you headed in this direction, the values would be more right. And so it's like, okay, so it tries some values that are closer to, it heads in the direction it believes is correct. And so, and then, you know, and it basically repeats iteratively until it finally gets to, it settles and what it thinks is like as accurate of as a model or an accurate of a line as it thinks it can get to. Well, I say thinks, but you know, once the error gets low enough, we're like, okay, good enough. So there's two pieces there. There's one which is the loss function. So basically, whenever this first arrow comes out, I'm sorry, when this first line appears, we have to be able to calculate how wrong it is, right? And so that's the loss function. The loss function is going to calculate how wrong our model is from our set of data. And then there's another piece called the optimize. I think it's called the optimize function. I don't know, there's a TensorFlow.optimize, and basically what that is going to do is that is going to pipe the loss function back into like the I guess the training function, the predict function, and it is going to the optimize function is what is going to slowly move the values of our coefficients towards our training set. So that's what is what is going to tune our m and our y equals mx plus b, our m and our b value until it gets there, and it does so using a method called stochastic gradient descent. So you'll hear gradient descent. It's something machine learning. It's a big fancy word that machine learning people love to throw around. But you know, basically what this means, and you can go watch other videos about it, is that is how we are going to approach what our optimize function is going to approach what it feels like is the correct value for our coefficients. So, and the reason why the gradient descent the reason why the gradient descent is used is because if you use like a linear descent, right, one of the things that would happen is, so if you look at this first one, and let's say we're like, okay, well, let's have it go, you know, if it's linear, then let's have it go in, you know, sets of 5 towards it. So one of the things that might happen is like it goes 5, and then it goes 5, and then it's going to overshoot it, and then it's going to go 5 back, and you know, it wouldn't, basically it would be a really inefficient way to train the model. Whereas like gradient descent, like the idea about it is like, if you think of gradient descent as like a bowl is what is typically used. And let me check my stream. I just did a hand motion. Okay, yeah, a bowl. It's typically like what's kind of visually used to like see, you know, because if it overshoots, right, if it goes to if it errs on the other side where it's like it's not like overfit, right, like our line appears on the bottom side like here, then it doesn't want to, you don't want to overshoot it in the other direction. So that's something called like oscillation, which is when you get into like controls theory, that's something that you have to kind of tune for and watch out for is you know, oscillation's bad. You want it. And so what the idea behind the gradient descent is we're going to like exponentially like approach what is the correct value, and think of it as like a ball rolling down into a bowl, right? Like, so, you know, it's going to tune all the variables until it gets to the very bottom, whereas like, okay, this is as good as we're going to be able to predict. So that's my loose understanding of it. I don't think I did a fantastic job of explaining it, but there are many videos out there that can do a better job. And so my personal favorite is this website called YouTube. Let's see, 3 brown, 1 blue, neural nets? Yeah. Yep. So I think, I'm not sure. Yeah, here we go. How machines learn. Gradient descent. So I recommend watching this video series. It's a great intro to how neural networks work, though we're not doing neural networks yet. But this kind of idea of training a model, right? Even though we're just training our super simple linear function, eventually we're going to swap out that linear function for something fancy. But let's get the basics first. Okay, so let's see. So I'm going to take one of these code pens, and I said there was a gist. Yeah, so I'm wondering here, everybody, yeah, uses NPM to do stuff, which is not going to work for us. Let's see. Yep, this is what we want. So they're using chart.js, we're not. We're using, so here's TensorFlow. So we'll get that. All right. So we've got Chartist, Lodash, and RxJS. We're doing all right for our dependencies right now. I mean, we're loading in everything. I think RxJS is kind of whatever. I'm not worried about that right now. Okay, what's going to end up happening though is I know we are going to, so this is going to be our integrations, and this is going to be our regressions. Wish I could put these side by side, but whatever. Okay, do that for now. So, all right, so we got all of our stuff in place. So what, you know, where did we leave off? Because I thought I mapped these out to a, well, first of all, where's my shell? All right, I guess I didn't have one. Yeah, okay, let's bring this up. Come on, sheesh. All right. Where is, yeah. Okay, we did all that. Did I? Okay. So we kind of lost our code there. No. What's today? Okay, so 15th. Should rename that tag. th 10th. So it would have been this. Stream. Wonder what this is. Oh, that's right. I didn't want to check in any of the awful code I was writing for the chart, which maybe in hindsight wasn't the greatest thing to do. Well, whatever. We can make our own chart later. Well, no, we lost something here. So we have, and okay, so our correction is there. Okay, and then we have the creator. Okay, yeah. So, well, anyways, whatever. Let's, okay, one of the things that I want to do, so let's take a linear regression on our 10-second window. Well, first, actually, before I do any of that, let's get us some space here. Oh my God. There. Let's get us some space. All right. So let's go through our example. So, okay. So we have our X and our Y values. It's different. So I might use the word tensor, just because since we're working with TensorFlow, but all a tensor is think of a tensor for now as an array. We'll cover two-dimensional tensors in a moment because I think we're going to have two-dimensional tensors. All right. So, okay. So this is their data, their training data. And so we're going to train our model on the stream of values that are coming in. So we shouldn't have, because we shouldn't have too many values, like, right? Like this, I think the 10-second window ended up not being having a crazy amount of values, which means we're going to get a less accurate linear regression. I mean, the more values, the better for the accuracy of our model. Well, actually not necessarily, but whatever. But this, we should be able to calculate this. My point is, we should be able to calculate a model on the fly. So let's see. Let me check. See if I have any comments in the stream for no particular reason. Wish I could make this bigger. Okay. Wait, someone's watching, or it's probably just me? Oh, okay. Or there's people watching. Cool. Hey, y'all. Okay. So, where was I? So here we are. Okay, we have. Let's copy this. So this is these are our coefficients right here. Like y equals mx plus b. Here's m and here's b as a part of that equation. So cool. I'm gonna change these to lits, just because everyone seems to prefer to call me out for using lit. I like lit. Okay, so what's happening here is we are creating a random number. And that's what scalar is. So a scalar in TensorFlow, when you're working with tensors, right? I don't know why I put tensors in quote, but whatever. When you're working with tensors, when you don't want a tensor, right? Like it's not a vector. You just have a value that's called a scalar. So we're creating, and that's what our coefficients are. Yeah, our coefficients are, is they're just a number. So that's what we're doing, is we're creating just a number. You can't just like throw in, right, like a number, because TensorFlow is like, I don't know how to apply that to other tensors. And then variable. And I think variable is basically is our way of letting TensorFlow know that, like, hey, this is something that we want to change, or something that you can change with your training magical goodness. Okay, so here we are. We have M and B. So these are going to come from our stream, which we'll deal with that in a minute, because I think right now I'm doing something. Well, we'll worry about that in a second. Because we're basically going to create a two-dimensional tensor, right? Or we have a two-dimensional tensor at some point where, you know, our x value is the timestamp that's coming in, and then our y value is the price. And for those that don't know, we're kind of building on top of, we have a stream of cryptocurrency. We connected to a WebSocket of cryptocurrency prices. And we basically are calculating we're doing a numeric approximation of an integral using the trapezoidal rule of a price stream for different given windows. So we have 10-second windows, 30-second, minute, 5-minute, 10 minutes. This is just wrong. I wonder where all the code went that I wrote on the stream the other night. It's like just missing. I wonder. Hang on, I'm gonna try to track this down. Cause maybe I stashed it. No. Shoot. I guess it's just gone. I mean, I'll have to try. I don't want to track it down right now, so whatever. I'm just gonna keep trucking with that. But yeah, I think. I mean, not that it matters. It's not like we wrote a meaningful amount of code that I'd be disappointed to lose out on. Right. Yeah, this is definitely old code. Back to TensorFlow. Got our variables. Cool. Let's Yeah, sweet. So let's just do this. Oh, wait. Yeah, let me get this going. No. No? Okay. Getting a web server going. Should be... Really? Oh. Using Python 6, huh? Or 3.6. So that means... Oh god, what is it? It's like... HTTP.server, I think? Like... Struggling. Okay, cool. Wait, what? Okay, yeah, it's fine. Cool, alright, so we know that works. Get out of it. Ah, shoot, I don't have a screen session. Yeah, there we go. That's why. I bet you this is... No, it is still 3206. Alright, so Python... There we go. Yep. Cool. All right, so we got our variables. Awesome. So now all this other fun stuff. All right. What is... Now why... Okay, he's just bad with indentation. So we have our predict and our loss function. Sounds good. Let's get them. All right. But we're gonna rewrite the way I like to write things. Bam. All right. So I'm gonna do that. Tidy. Get out of here. So you don't take anything. Okay. Oops. All right. This, for whatever reason, this is easier for me to read at this point than this. Let's loss equals and for some reason, yeah, they did that so they could put a comment in there. All right, cool. All right, so we have all the pieces to the puzzle here. Okay. So let's break these down. Predict is our... Right, so this is our function. This is our model, right? We're making a linear regression model, and this is a linear function, right? This is mx plus b. So this is, so m, right? Boom, this guy. Times x. So x is coming in from our stream. So, and this is going to be a Unix timestamp. So given f of x, so in this, I mean, I guess this is f of x, right? For our linear regression model. So anyway, so here we go, m times x, and then the product of that, we're going to add b, which is our other variable. So I'm just gonna x plus b, right? So x on there. All right. So this is going to give us y. This is our predict function, right? So this is given what the current value of m and b are. This is going to say like, okay, we've got a function, we can give us an x and we'll tell you what the y is. And so what's going to happen is this is going to be what is used for, this is the output of our model, right? And so like this is going to spit out a y value, and then we're going to check it against a real y value, and then we're going to have an error between those two. And that's what the loss function is going to do. So for given a stream of values, right, we're going to calculate, right, a stream of predictions along with it. And then we're going to, and then what our loss function does is it is going to, now this is, it's going to calculate the error between what we predicted and what is real. And it is going, and then, right, and then we're going to use our optimize function to use gradient descent to slowly get to what the correct values of M and B are for a given stream of values. Okay, so now this is a particular like statistics error calculator, and I think it's like means, well, okay, let's take a look at it. So prediction, so this is going to be the output of predict, right? So this is going to be some y value. So we're going to subtract labels. I'm not sure what labels is. If I had to guess, I would think that this is going to be an array, tensor, whatever, of real values or a single value. Either that or prediction, or either that or the prediction is going to also be a tensor of values, right? And so this is, these are real, this is the output of our function. So what we're gonna do is we're gonna stretch, so this is our error right here, right? The difference between what we predicted and what's real. And then we take what we subtracted and we're going to square them, and then we're gonna take the average. So difference square mean. I know that this happens, so I know that there's like a mean squared error. And I think that's what this is, a mean squared error. So error, right? So subtraction, that's error. Mean square. Let's see if we're right. I know this is in here somewhere. Loss function, right? Mean squared error. Yeah. All right. I was right. Yay. And what? So, oh, in this tidy function, I don't know what this is, but all the examples use it. I think this has to do with garbage collection. I'm not gonna worry about it. Just if they use it, I'm gonna use it too. We'll figure out the subtleties of why this is important, I'm sure, at some point. Okay. So we've got our predict and we've got our loss function. So now we need to optimize these two functions, which is our train function. Okay. So now he's got some stuff where like he writes to the DOM after he trains like each time, which I'm not really all that interested in. I'm mostly interested, I just want it to train and then I want the completed model, if you will. So we're gonna have to mess with this a little bit. So, but let's take this. Actually, you know what I want to do? Optimize. It's going to be equal to, because I think optimizer returns an optimized function. So let's just do this real quick. And we are going to get rid of you, we're going to get rid of you, we're going to get rid of that. Okay. Right. Now, so I think I'm gonna, okay, well let's walk through this first. So there's our predicted y's, right? So, okay, so this is our predictions. That's what confused me. So, okay, here's our x, here's our y. So these are going to be grabbed from our training set. So, right, so this is going to be a stream of values that we get from our window. Which is fine. So I might wanna, do I wanna thunk this? Meh. We'll figure this out later. I don't like that this is reaching into the closure. And so I have a feeling I'm gonna end up doing something like, oops. Well, let's just do it now. Yeah. Okay, anyways, let's deconstruct what's going on here. So predict, all right, okay, so we have a stream. We have a stream, or sorry, we have an X, yeah, we have an array of X values. So we'll definitely be able to get this from the observable. And then we're turning that into a tensor. All right, and so predict, right? And so that we're gonna pipe this into, okay, yeah. So this is our model right here. Well, sorry. Yeah, no, well, it's not our model, I don't guess. I guess this is our function. Our model is going to be the output of optimize, which is going to be our tuned function. Okay, so this makes sense to me. So I'm going to rewrite this to be all functional programming, because that's how I roll. Yeah, do this. So, I like reading point free. If you don't, I'm sorry. Yeah. Right, so there's our actual values. Okay, yeah, okay. So the stream that's going to be coming in is going to act as our training set for our model. And then we're going to be able to, yeah, make predictions. Cool. I am super excited about this. All right, so we have our predict function, we have our loss function, we have our optimize function. All right. Let's see. Okay. So I think I'm gonna, let's go to his gist. Train. Oh, he did end up using a... okay. So we actually need to do... We'll have to figure out what plot is. Okay, we actually need to create an optimizer. Which maybe we'll do this in our spot where we initialize stuff. I don't know what learning rate is. Just straight up. I don't think we need it, so, or... Alright. I get the distinct feeling we're gonna need this at some point. Alright, so what this, yep, data, plot, yeah, okay, I don't really care about all this. We're gonna do this on our own. We're gonna create our own chart later. What I'm mostly interested in is where do we get the predicted value, or I guess predict after we train. I wonder, I bet you this is synchronous. So, yeah. Because otherwise, plot, train X, train Y. And then, how do you get your data? B, data sync. Oh, wait, that's the label. B data sync, M data sync B. 11x plus B. I wonder why 11. Oh, because that's the number of x values. Why did we want 11? Well, I think the point here is this is mx plus b. So this is once we train, right, we can go fetch what the values of our coefficients are. Interesting. Let's see if this has any tricks that we'd like to know. Nope. TensorFlow print. Optimize. Yep. Do we even use this? Crap. Oh, wait. You know what? Alright, we're gonna have to adjust our stream a little bit. You know what? Let's create a new stream. Alright. Problem is, and we don't have trapezoidal, right? Yeah, cool. So this is just gonna give me with latest ROM, window filter. Okay, this is gonna give us a, yeah, I think this is what we want. So let's do what is it, 10 seconds dot subscribe. All right, this should be interesting. Okay, so I can get rid of this actually, because we have our x and our y from our value here. Okay, but what I'm gonna do is comment all that out. Let's see what we get for my stream at this point. Right. Price. It's okay, it's not X and Y, it's YX. So let's just do that. Alright, so now we got everything we need. Let's off to the races, let's see what happens. I don't know if this actually returns anything, but what was it? So this guy like printed out, or was it flow.js print? Let me check if there's any comments. Oh, whoops, get out of there. Nope, no comments. Anyone even watching? I don't know if that's true. Okay. Yep. Print. Is that just gonna give me like a... Is that gonna console log for me? Yeah, it will. Sweet. Alright. Print. What would actually be cool if like we can hang on to like the last like value of M and B and then initialize with like that instead of random values. Go into that later. Oh, I'm a genius, y'all. Alright. Let's see what happens. Come on, do something cool. Aw. Tensor 1D, so we're minimize. Who's not a tensor? Oh. So let's... Oh, right, this is values. Wait. Right, oh crap. Okay, so we have X and Y coming in as a pair. Do they? Hold on. Yeah, hang on. I'm doing this all wrong. So this one's a tensor. I have a feeling we're gonna have to do a map. So... Actually, yeah, hold on. So this is gonna be our whatever, V. So as X's come in, we're gonna do an, wait, nope. V.map. Then, or actually, this is where X and Y are. So Y is the first one, X is the second one. We're gonna return X. So there we go. We're gonna have an array of X values here. Oops. Array of Y values here. I think that's what we want. Yeah, predict from based on X, yeah. Cool, let's try that. All right, cool. What does it mean? Okay. Here's what we're gonna do. Now that we have so we're gonna take our model and we're going to predict the future value, and then we are going to see how cool that value is. I wish it would, why won't you tell me which? I mean, I'm assuming that this is probably... M, right? It's gonna be this very, very tiny number. Which I think is kind of cool. Okay. This one scares me. Make predictions. I don't know. probably read this. Quadratic, right? Not polynomial. Oh, I like that. I like that syntax better. Loss, learning rate, yep. Now how... Am I just training the model once? This is saying... Predictions equals F. Right. So F here is going to be our predict. XS. X's, Y's. Predictions. So what are you training on though? Now this, okay, this is just gonna spit it back out because it's using X of S for his training set as well as for his prediction set. But datasync does seem to be our... So, actually, why don't we do that? Oh my god. Nope. Nope. There it is. See if this works. Yeah, are you only one value? Yeah, you're only one value. Alright, so that's definitely M, that's definitely B. Problem is we don't know when the next value is going to come in, right? So what we ought to do, so we're training our model constantly. This is, we've trained based on the new values that come in. So what I feel like we train it based on a random value for each value that comes in. There's part of me, okay, I think what I want to do, I want to do these up here and let it, instead of initializing a training set or from a random point each time, this is how we'll go from the previous, what the previous iteration had. Alright, let's get that out of there. I'm just gonna get you out of there. Let's see. I want to see what M and B are each time. What's... No. You know what? And all of these, I believe, can be put. Well, the only thing that I think we need is the optimizer, yeah. So these can all be up here. Where's X? X is there. Where's B? B's up there. So the only thing that comes through that matters is our training set. Now, and are we only training once here? That's my question. Because there's part of me... There's something I'm missing here. Like, so... Are we... How often are we... So he's only training once too. You know what? Maybe that's fine. Because we're training on the entire set of values each time? On the... Instead of... So in this example, they are just still a one-dimensional TensorFlow, yeah. Tensor. Huh. All right. Yeah. Why 10? Why are we training it 10 times? You know what? I mean, since we're doing it every value that comes in, let's just keep this the way it is. Okay. Wow, it actually kind of took a second to calculate. I bet your learning rate is gonna have to, we're gonna have to play with that some. Oh. Alright, alright. I don't think it likes using the same M and B. Oh, okay. Alright, alright. Message received. Yes, it is. Oh. Shut up. I wonder... I mean, let's see. If just moving those guys out was the problem. Yep. Okay. So for whatever reason, I wonder if it has to do with tidy. Like tidy is going to garbage collect these. Problem. I bet you it does. I bet you that's something's going on there. Alright. Alright, and you're gonna complain about. Alright. Let's try this. Alright, it's much happier now. I do wonder, though. Print out our prices. No, right. No. Doesn't really matter. Right, so our model is actually going to be pretty inaccurate at the very beginning. Now it seems like it's better. Alright, let's break this down. So we got a good set of values here. We got 14 values for it to base its on. So we have a positive slope and not the tiny... Oh, wait, these are random values. Okay. So, this seems to believe that the... I don't know how much I care about the Y value. I am gonna say I am suspicious that we are getting such a large negative number as our Y-intercept when all of the values kind of seem to be... in the 290s, right? I wonder if this has to do with my X values. So let's see, so 295, 17, 17, 17. So we stayed consistent there for a while. And then we went up a little bit. So we mostly went up. So having a negative slope jumps out to me as wrong since our values only went up. So we should have a very slightly upward slope. Negative. Well, you know, I say that. Yeah. Something doesn't feel right. I have a feeling it has to do with our optimizer. So let's actually go through. So he's got some debug code somewhere in here. I think it says just. So predicted wise. We'll see how many times our optimizer should be running quite a bit. So I'm wondering. Yeah, no, maybe not. How many times do we run train? Where's train getting called? Just once, okay. So that seems right. Alright, but let's do this number here. Let's break this up. So this wants to step loss. Just gonna... Because it's one number? Yeah, that's fine. Okay, so predicted wise, and our loss. So... What am I doing? tensors. What? Actually, print already does that, right? So. So for one thing, check on the stream. Still there? Well, according to this, you are. Nope. Alright. So yeah, optimize is only being called once. Let's learn up some optimize. So our predict function, which is our f of x, so what are we passing in predict? No, we don't want to pass in a tensor 1D. We want to predict a so print y is the first one after optimize. Let's find us a good one. Now let me make sure these are date stamps. Nope. It's not a date stamp. But, wait, hold on. So optimize, first thing we're printing is our predicted wise. So, okay, so given, hang on. Where's V? Okay. Alright, here we go. 3 values. 3 values based on the fact. So these are predicted Y values, and this is our loss. Our training set, what's going on? These are all of our predictions. This is what our error is. Optimize only. So I feel like we're not training our model enough. I feel like that's the problem. So okay, so these are predicted Y values. I think I should maybe print what M and B are initially. Let's do that. Can't you do, hang on. I think this is a thing. Yeah, sweet. We're not training our, so I have a feeling, so I was following this, and this guy trains his model on each click. I have a feeling we want to train our model more, yeah. Because we're only, yeah, okay. So, let's train it 1 million times. No, I don't, Hey, look, 75. We're gonna train it 75 times. Also, that learning rate's a lot higher than ours. Ours is like super. You know what? We're gonna bump that up. We're gonna crash my browser. I hate for loops. I'm gonna use one though. Just to play ball with everybody. Because I don't feel like... I'm just calling it right now. I'm gonna regret this. I am absolutely going to regret 75. This for loop. Alright, let's let's crash our browser. Yeah, there we go. Okay. Okay, cool. Not what I wanted. Now why? So it was cool with it at first, and then... Let's bump this back down. So, I mean, then again, we are like training it a lot for only having like a couple of values of data. So I'm kind of wondering if like, yeah, we should actually probably do, dot length for now. So that way, because I think we might be oversampling. Yep, I did crash my browser. Come on, simmer down now. Oh boy. Still, somehow Twitch is using more than me training my linear regression. Yeah, there we go. I think I might have to relaunch Depth also. Oof. It is struggling. Okay. What am I doing here? Lots of stuff. Okay, so it does start shitting the bed. Why, though? So, okay, so we have a healthy number of... Wish I could stop it, but... So, optimize... It just did not like... I feel like... Okay, so I'm printing out and optimize. I'm printing out the predictions, then the error. So the predictions for the first one... Maybe I should print out... I wonder if... No... block. Let's print out. Let's do this. Okay. So M and B. Predictions or predicted Y value. Slope? No, that's our loss. Or a mean squared error, excuse me. Okay. So when is it? The wheels start. Okay, here's a good one. The wheels are good and falling off. What happened? Okay, so we started off a couple values, and we're like, okay, maybe this for value. I think this is too small. So we get these as a predicted value. Or wait, no, too big. Yeah, these are huge. That's probably what's happening. Is like we're going out the roof. Okay. Well, I wonder, does this have to do with the learning rate? I mean, I feel like... Right, so, you know, what happens is eventually from our... So this is mean squared error. So what we're going to do is we're going to subtract all of these from the x values. So the x value, these predicted y's. So that's actually going to be like a fart in a hurricane, right? Because, okay, so, and why are these so big? So we have m, so it's going to be this times our x value, which is going to be some timestamp. In milliseconds, right? Let's print out x. Just, you know what, just give me B. Cool. There we go. All right, we're good and broke here. So after, yeah, not a number. It's because we're multiplying or dividing by infinity. But anyway, so V here, what do we got? All right, so this is a huge number. However it works, down to the millisecond. Or wait, microseconds? Alright, let's see. So if we take those three off, what do you think that is? Okay. I think it meant milliseconds. I think this is in milliseconds, not microseconds. Alright. Anyways, where were we? Alright. So here are our predicted y's, which are going to be... So basically what we got was we got this times this. let's check out spreadsheet. I don't wanna worry about this one. Maybe I just do this on. Anybody watching? Cool. Alright, because it's gonna be this times the... Or wait, let's do the... Yeah, it's gonna be this times this. Assuming the first one, yeah, it's M. I think it's the mean squared error is just blowing us out. So this, if these are multiplied, this should just be half, right? So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6. So we should see a decimal right here. So I predicted Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't think that worked at all. Right? Multiplying by a half. Shouldn't that half it? Alright, you know what? I don't feel like dealing with you. Ooh! Finally came up. Alright. Sorry. We want to go back to here. I might do this, though that's, I'm sure, probably grinding this. Times this. 971. Okay, maybe I'm just 971 942 57. Whatever. Rounding error aside. So this is roughly right. All right. And then plus this, right, which is a fart in a hurricane, as Dad would say. All right, so we've got this thing. So, okay, so I trust all of these values are probably accurate. Well, you know, I say that. So, 60, 194, 2133, 2129. Okay, so it looks like there is like a pretty non-trivial rounding error, which probably just has to do with. Is this an integer? This is an integer. I wonder if like. What if we did a 2 float? Well, whatever. I don't feel like. Okay. Anyways. So these are 6 here, 6 here, 6 here. Okay. It's interesting to me that all of these are the same number. I wonder if we convert this to seconds. Would that make things easier? Or if we multiply our random number, give it a couple decimal spaces, so that way those numbers don't turn out so huge. Let's try that. Nope. No better. Those numbers are still huge. Okay, well. What about, let's turn seconds into milliseconds here. Can I do a, there's a dot pipe, but can I do this? Return an array with our V, or no, Y, X. Nope, that's not it. This is V. This is going to be the tensor, our two-dimensional tensor. So we actually want to do a map on this, and we want to, now we have our Y, X. If I were smart, I think I'd be able to, or if I converted these to a tensor, which might be smart, I could just divide X by 2, but whatever. So we're just going to return our original X value, and then we are going to divide our Y value by 100. We're going to go for seconds instead of milliseconds. Ah, man. Pipe. Map. Sort of look better, right? All right, we're getting not a number on. All right, what are you getting? Oh, come on. Well, what's Y? Why not? Why is Y not a number? All right. Wait, something's not right here. V is not what I think it is. I'm getting the distinct feeling that we actually might... Okay, hold on. Just... Maybe I've got myself all turned around, which I really like to do. Let's see what's in there. Oh. Okay, so I had that right. Oh, duh. We want to divide the X value, not the Y value. Wait, and I don't want to, that's the dumbest thing I think I've ever done. We want to move the decimal, so yeah, multiply by 100. Well, what we got then? Wait, what? Why are you? Oh. I think that was my error, like, all along. Make sure you're the right value. Wait, oh my god. the decimal the other direction. And it turns it into a float anyway, so that makes me happy. Let me make sure that this is what I think it is. Yes, it is. Alright. Now, I didn't like that better. Oh, there they are. Okay. So we got these big numbers. Yeah, I don't know. I'm gonna go back and take this out. Okay. So here's where it barfs. So, okay, look at this giant negative number. This has got to be like a mean squared error. It's just hitting the roof. So... this. Times this. One 47731. 319808 9821. Same deal. All these are the same number. Is it because these are the same? But that's not the same. You should be different. Well, I wonder if you're within the frickin' whatever error we're hitting here. Okay. So I'm kind of wondering if we might need to zero out our x values or have them be relative instead. Well, just take the difference from the oldest value for each value. So f of 0 is blah blah blah. Keep this from hitting the roof. Alright, let's try it. Let us try it. Alright, so... crap. We got all sorts of good stuff we're gonna have to do here. So we are gonna have a reduce. I think so 0 is our so they're going up, so 0 is always going to be our oldest value. So x is going to be equal to x minus oldest value. Let's just do a, yeah, we got a tap there, we're good. Yeah. Ay, ay, ay. Right. What? Why didn't that work? We initialize reduce with an initial value, right? Oh. Cool. Now why are you complaining? So it should be, yep, that. Minimize, what are you complaining about? Who's not v.map? Oh, what's, so v, it, undefined is not a function, tensor v1 dot. Huh? V that comes in? The tap should be, so console log, well, I mean, it doesn't matter which side we do this on, right? These should be the same values. Okay, I'm not sure why. Let's pause on the debugger, because V should be an array. Well, what's V? Come on, tell me. What is V? V is not defined, huh? It's right there, though. Is this like the... This seems weird. Maybe it's because V's here? So we got reduce. I wonder if it's... X and Y values. I think we might be flat. Yeah, we're flattening it. We don't want to be. Shoot, why am I flattening it? You know what? I need to keep returning the oldest value. Shoot. Okay, so it's not a reduce, it's a map then. And instead of oldest value, we're just gonna go read what the oldest value is from V each time. Oh, right. Get out of here. Now, what you can play about now? Same thing? Oh, right. Oh my god. Okay, I'm gonna give this another not that long, and then I'm gonna call it. I'm sure this is full of values. Okay, we're still blowing out the top. I think we're doing better though. Wait, hold on. This one work? Are we? Okay, there we go. So when we start getting a lot of values, it seems like... and which one is this one? So this is optimize. The like third thing we print. Our predictions, okay. Oh wait, no, that should be the loss. Because, okay, right. It's gonna be A, M, B, predictions, loss. Okay, so these values got big enough that we blew out the roof again. Huh. So what's happening? So as we're training, let's take a look here. I mean, so I think there's an improvement here. We had to get to 6 values before crazy stuff started happening. All right, so let's take a look at our list. Well, first of all, yeah, so I was wondering about this. If we get 2 values for the same point in time, then that kind of throws math for a loop, right? That's a non-deterministic function. Alright, so maybe we can... I think it's... Hey. I'm happy with, right? That is a huge slope though. Hold on. That is a massive slope. Yeah. And take these out for now. Some console log management here, just to make it a little more clear what I'm looking at. And I'm gonna have to change the music. Oops. Where were we? Okay. Do we lock up the browser? I'm gonna close like all of these. Alright, so we got 3 values. Okay, but it was happy. Those 3 values. It's actually been pretty happy, but we haven't gotten like a swath of values yet. Let's just wait for that to happen. Check on the stream. Is anybody watching? Nope. Womp womp. But YouTube. Got anything bad? Nope, nothing. Does not look like we're getting very many values in though. Here we go. Yeah, that's what I'm talking about. Okay, we got this BS. It still handled it though. And a slope of... That's actually a massive slope. Or massively negative slope. Okay. I wonder if we're at a point where we might want to start graphing what's going on. All right. I'm also kind of wondering if we're like, yeah. Seems like we can get into some like, man, that is really upsetting me when this duplicate values come in like that. It's funny, so our slope is huge, it's going up, straight up. This one's like our slope is down, way down. Alright, what are we doing? Line, yeah. How do we do a line? Well, you know what? Oh my god, come on. What is this? All right. regressions. Can I do no labels? Does that work? Alright. So we've got one series. I don't want any padding. Got one series, and so we want 2 values. One being, first, let's put these somewhere. Right. I wonder if that blew up. No? Okay. No, whatever. Maybe it did? Just gonna get a price. Right. There you go. Maybe? I don't know. Nah, come on, where are y'all? I'd love to. Ay. Struggles real today. Okay. So we should have some values. We don't. What? What? Oh, right. We have to get the X value. There we go. All right, we got our slope. All right, let's get another one for price. Oh wait, no, I should just do a map here. Yeah. Oh, should probably rename this to price. I threw it for a loop. Yeah. Blowing out the top again. Betcha it came back. Yeah. Let's turn our learning rate like way down. See what happens. So far, so good. Well, that's wrong. I don't know. Oh, it's next to the bed. Okay. I think I'm done for now. This was fun though, but as I expected, TensorFlow is not quite as like straightforward as like all these like pretty little articles like make it out to be. Like there's a little more to it than that, especially when you hook it up to live values. Like hooking it up to like regular values, I think, not that it's meaningless, but it's certainly a lot easier to deal with. Well, let me take a look in here real quick. Right, so one thing that's happening is whatever our function is not producing something that's along our line. So there's definitely something's up in our optimizer. Okay, well, I'm done. Fight it more a different day. Thanks, if anyone tuned in.